College of Engineering and Technology near Anjigramam Junction, Kanyakumari Main Road, Palkulam, Variur.
The Burj Khalifa in Dubai is the tallest man-made feature on the face of the planet, and one of the greatest achievements in engineering history. To dream it up took outrageous ambition. To put it together requires nerves of steel. Constructing cranes taller, installing windows higher, and building bigger than ever before. As the construction team makes history, they film it themselves. This is the story of one incredible skyscraper, and the people risking their reputations and their lives to build it. Six years earlier, when construction started, it was little more than a barren, parched, and sun-baked desert. In February 2004, the team breaks ground at the Burj site. With large parts of the structure still on the drawing board, the construction team heads into the sky. The fastest way to build a tower like the Burj is with reinforced concrete, using a process called jump forming. The team builds molds at the base. They insert steel reinforcement bars and pour in concrete. Then when the concrete sets, the team lifts the molds up to the next level. And the process starts again. Using this system, the building begins growing at the pace of one new floor every week. To create a taller tower with bright internal spaces, Bill and his team devise a new structural system.
The structural system we use for the Burj Khalifa is the buttress core. Now the core is the center hexagon in the middle of the building, and that's what's used to resist the twisting forces on the building, okay? But it's much too slender to go to such great heights. So it needs to be buttressed. Now the buttresses are the three wings that come off. It's consisting of these walls that go down the corridors. So you can see how this core has been buttressed in three directions. That's why the structure going on the wings. To my knowledge, it's never been done anywhere else. And so it's a unique solution to a very interesting problem.
With the buttressed core concept, natural light floods the interior.
We've come up with a solution which allows us to go very, very tall, but it's light and airy on the inside. It's as if you're in a 10-story building rather than a 160-story building.
In SOM's design, the large tower base helps support the huge weight of steel and concrete. Then, as the building climbs, the buttresses step back in a rising spiral. The team then coats the design in glistening mirrored glass to reflect the desert heat and light. The team uses over 25 separate ingredients to create concrete that stays liquid as it's pumped up the building and then turns solid extremely fast. But getting this special mix to set is a massive challenge in Dubai. with temperatures rising over 45 degrees Celsius. To lift this mix up the building, the construction team uses 3 of the world's most powerful concrete pumps. Over 32 months, the pumps deliver 165,000 cubic meters of concrete, enough to lay a sidewalk 880 kilometers long. When complete, the Burj will stand 828 meters above the ground. The question is, are the foundations strong enough to hold it up? Early on in construction, analysis of the ground under the site highlighted a problem.
It's not like, when I worked in New York City, you get good granite there, you go down 4 or 5 meters, you're into good granite, and that's what you sit your foundation on, the granite itself. Here the ground is top layer of sand, 3 or 4 meters of sand, and you get into weak sandstones, weak limestones, nothing very good.
But science provides the answer. The future of the Burj Khalifa and its entire colossal weight rests on one scientific principle: friction.
There's basically 2 methods in piling. One is end-bearing piles, which is you put the pile directly on the hard rock. That's what can sustain the load. But here we went with skin friction piles, where the weight of the tower is carried on the friction of the pile, the side of the pile.
The foundations of the Burj rely on the super strong grip created between the ground and the sides of each pile. Beneath the tower, the team has driven 192 piles to a depth of 50 meters to support a 3.7 meter thick raft of solid concrete. These foundations must hold up a building that weighs over 500,000 tons. The numbers are so big that the team has to allow for a small degree of settling in the design. 3 years after breaking ground, construction reaches 512 meters and 141 floors. The Burj is now the tallest building on Earth. The panels are up to 6.4 meters long and weigh up to 750 kilograms. And every single one must be lifted individually and installed by hand.
It's very dangerous. You can imagine these panels are quite large, and as soon as the wind grabs them, they're like a big sail, so very difficult to control. The panel could go flying back into the building, the glass would break, and you're going to get a shower of glass coming down the building. A guy could get his legs cut open and stuff like that. It's quite dangerous.
The curtain wall is virtually finished. Meanwhile, further up, the building has yet to reach its final height. The construction team must crown the structure with one of the most extraordinary pieces of engineering ever attempted. A 136-meter tall steel pipe, weighing over 350 tons and measuring just 1.2 meters across at the very top. But there's a huge problem. How to lift the spire and place it on top of the building.
The thing is that we couldn't get the crane high enough up to set the spire. Even with the crane at maximum boom height, it couldn't get anywhere near the top of the spire.
No crane in the world can handle this job, and no helicopter can lift 350 tons of steel. It seems the spire is too big, and its destination too high. But then, an engineer suggests an ingenious solution. Lift the spire in pieces and assemble it inside the building. All the lead architects and engineers gather to see the spire rise into its final position. For the first time, the silhouette of the Burj is complete. The team can now start to apply the finishing touches. This building doesn't just have to be the tallest in the world, it also has to be the best.